now we are going to discuss power lost in color and footstep bearing. Okay. Now see here, we have in the last class we have already discussed power lost in bush bearing. Now here this is collar, okay, and this one is R1, this one R2, okay. So if you take another view, this one have like this. This is equal to R1, okay, and another is R2, this one. This one will be R2, and this is bush, this is the footstep. See here, power lost in color, this is the color, okay. So this one will have a small ring of radius r at thickness dr. So this one at r and thickness dr, okay. This is similar to this one. See here, this is this, okay, and this we are having this. So this one is smaller radius R1 and outer color radius is R2, and in between this one, this while viscous while is used, and that is clearance, okay. So B. So here also same thing, when it starts rotating, when bearing starts rotating, frictional resistance is created or produced, okay. Now torque or power is required to overcome this frictional resistance, okay. So that is why we are studying this one. Here also we are finding out how much torque or power is required to overcome this frictional resistance, okay. So this is when the bearing starts rotating, frictional resistance is produced. Torque or power is required to overcome this frictional resistance, okay. From here also we can start. So tau is equal to, as usual, mu into u by b, okay. As usual, this is Newton's law of viscosity. So here mu is equal to this one. So force will be tau into area, okay. That is shear stress. So shear stress is mu u by b into 2 pi r dr. Thin ring, considering thin ring of radius r and thickness delta r. So this one will be there. This is force, okay. Now here see here, force will be mu, V is equal to omega into r, by b into 2 pi r into dr. Okay, this is the force. So force will be equal to mu omega into 2 pi r square dr by b also. Am I right? But remember, torque will be equal to T will be equal to force into radius. So it will be mu omega 2 pi into r cube dr by b. Okay, so we can call it as dt. Now, taking the integration, this in between limits r1 and r2, because two radius are there. Remember, this color bearing is used to take care of axial load. Okay, axial, when the load is axial, then we use the color bearing. Okay, so this is the color. Now this is torque. Okay, now what we have to do? We have to find out the torque of color bearing can be found out. Torque of the color bearing can be found out by integrating, that is dt, integration of this one, pi omega 2 pi into r cube dr by b. Okay, so this is b. Now see here, this is pi omega 2 pi by b into integration between r2 and r1. Okay, so it will be r to the power r2 to the power 4 minus r1, not capital, small, because we have used r2, and here also r1 to the power 4 by 4, because here r cube integration dr is nothing but r to the power 4 by 4. So 4 we have taken out. So this one pi mu 2b by b into r2 square, r2 to the power 4 minus r1 to the power 4 divided by 4. So 4b. Okay, so this is the equation to find out the torque. Integrating this one, this will give the torque. Now our power will be here also 2 pi nt divided by 60,000 when n is in rpm and torque is in Newton meter. Okay, that is the difference. Now here footstep bearing, for footstep bearing we are going to use r1 is equal to 0. That is a special type of bearing where this will not be there. Okay, this part will not be there. So in footstep bearing, so torque will be equal to how much? Mu omega 2 mu omega b into r2 to the power 4 divided by 4b. Okay, only this parts become 0, so that is in footstep bearing. Okay, so this one, these are the losses in color or footstep bearing. In the last class we have already discussed power loss in bush bearing. Okay, so let us sum up what we have studied in this class. Power loss in color and footstep bearing. Color bearing is used to take care of axial load. When the shaft rotating, bearing starts rotating, then frictional resistance is created due to the presence of oil. So power or torque is required to overcome this frictional resistance. Now starting from tau is equal to mu u by v, that we have already in Newton's law of viscosity we know. So this is shear stress. So force will be shear stress into area. Area is 2 pi r. This is considering thin ring of radius r and thickness delta r. Okay, so 2 pi r into delta r. So mu, this f will be mu omega, v is equal to omega into r. Okay, so omega into r by b into 2 pi r into dr. So it will be 2 pi mu omega, and it will be r square into dr by b, but torque will be force into radius. So it will be mu omega into 2 pi by b into rq dr. Now we have to integrate this equation in between limit r1 and r2. So torque of the color bearing will be integrating this dt equation. See, pi mu 2 pi by b will be equal to r to the power rq dr. So it will be r to the power 4 by 4. Okay, so 4 we can take it out, and putting the limits r2 to the power 4 minus r1 to the power 4, it will have mu omega 2 pi, not 2b, 2 pi, because this pi is coming. So this will have equation r2 to the power 4 minus r1 to the power 4 by, this is 4 and b. Now how to find out the power loss? That is 2 pi nt divided by 60,000. And remember that footstep bearing, in footstep bearing r1 becomes 0. So it will be 2 mu omega pi, not b actually. Okay, so that is pi. From there we have got it. So it is 2 mu omega pi, 2 pi mu omega into r2 to the power 4 by 4b. Okay, so based on this one syllabus, I have completed this unit theoretically, and I am going to solve the numericals in the next class. Thank you.